Now we're going to talk about Pascal's triangle. Pascal's triangle is a really cool way, really fast way to help you expand a binomial raised to a power, something like a plus b to the n power. Pascal's triangle looks like this. There are ones along the diagonals, so 1, 1, okay, and then we have another 1 here because this is the diagonal, the sides, and then we add these. 1 plus 1 is 2. Here's another 1 because it's the edge. Then we have a 1. 1 plus 2 is 3. 2 plus 1 is 3. Then we have another 1. 1 along the edge. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And a 1 on the edge. A 1 on the edge. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And a 1. A 1 on the edge. A 6. 15, 20, 15, 6, and a 1, a 7, 21, 35, 35, 21, 7, 1, and so on. So let me just give you a couple of examples of how to use this, how this makes life easy. So we are going to expand. Let's do 2x plus y squared. Let's do it to the third power. We'll start with that one. So we go to Pascal's triangle and want this power, this n right here, the power is n on the outside. That tells us what row to use. We want the row with the 3's. So these guys, the 1, 3, 3, 1 are coefficients. I'm going to scroll down just a little bit. We are going to take the first term and we're going to raise it to powers starting with 3 and then lower it by the number 1 until we get to 0. So the powers of this one will be 2x cubed, 2x squared, 2x to the 0. Okay, so let me write that part. So I have 2x cubed. So these are going to go 3, 2, 1, 0, the powers. The back term, the y squared, starts out with the 0 power. Okay? I'll add the coefficients in just a minute. So this guy now is 2x squared, and then the y squared power raises by 1. Then we'll have 2x to the 1, and then y squared to the 2. Then we'll have 2x to the 0 and y squared cubed. So we're not quite done, but let's talk about what we've done. The first piece in the parentheses, powers go 3, 2, 1, 0. The second term in the parentheses in the back goes 0, 1, 2, 3 for powers. Then we're going to use these numbers from Pascal's triangle for my coefficients. I'm going to put them in blue. I have a 1, a 3, and a 1. This is a lot faster than if you just write this 3 times side by side and expand it out. So then we just worry about these powers. How do we expand these things with powers? So we have 2x all cubed. That's 8x cubed. We have y squared to the 0, so that's 1 plus. We have 3 times 2x squared. That's 4x squared. And then we also have a y squared from that term. Then we have 3 times 2x, and then y squared squared is y to the 4th. 2x all to the 0 power is 1. And here we have y. When you raise a power to a power, you multiply. So this is y squared cubed, y to the 6th. So we'll clean up a little bit more. This is 8x cubed plus 12x squared, y squared, plus 6x, y to the 4th, plus y to the 6th. And that's how we expand that one. Let's try one more. Let's expand. Let's do, I'm going to do something just a little bit easier. We'll do something with 7. We'll just do x minus y to the 7th. just so you can see how to do a bigger one. Now notice, remember here, if you had the 2 and the x was raised to the power that we needed. Okay, so just to make this a little easier, because I'm going to use all these big numbers, but I wanted to show you how to expand it. So there's a 7, so I'm going to use the row with the first 7 in it. Okay, I'm going to scroll down a little bit more. Now I want you to think about this in terms of, this is like x plus negative y to the 7th. Because when you use Pascal's triangle, it's a plus b all to the end. There's a plus sign in the middle. So my first term is x, my second term is negative y. Okay, so I take x to the 7th, and then I have negative y to the 0. Let me do it again in red like I did before. Negative y to the 0. Then I'm going to add x to the 6th times negative y to the 1. And I'm going to add x to the 5th times negative y to the 2. Plus x to the 4th times negative y cubed plus x to the 5th times negative y to the 4th. Put it down here. Plus x cubed times negative y to the 5th plus x squared times negative y all to the 6th plus x to the 1 times negative y 7, 6, 5. Oh, I screwed this one up. Sorry. So 7, 6, 5, 4. This should be a 3. My bad. 3. The 2. This should be a 1. And this is a 0. Okay. And I knew I screwed it up. It took me a minute, but I knew I screwed it up because my powers didn't count down right. So there you go. That's how you tell if you messed up. Okay, so powers of the first one are 7, 6, 5, 4, 3, 2, 1, 0. Powers of the back go 0, 1, 2, 3, 4, 5, 6, 7. I use my coefficients from Pascal's triangle. 1, 7, 21, 35, 35, 21, 7, 7, and 1. So 1, 7, 21, 35, 35, 21, 7, and 1. Now we clean it up just like we did on the previous example. I'm going to scroll a little bit down a little bit. Okay, so this, anything to the 0 power is 1, so I get x to the 7th. Okay, now I have 7x to the 6th, and I have negative y to the positive 1. So that means I keep that negative. So I have negative 7x to the 6th y. Okay, now if I look at the power of y here, it's squared. So that negative sign is also squared. So a negative times a negative is a positive. I keep the plus. Plus 21x to the 5th y squared. Now look at this, negative y is cubed. So that's a negative times a negative times a negative. I end up with a negative, so this changes to a negative 35 x to the 4th y cubed. Looking at this one, I have negative y to the 4th power. So that's a negative times a negative times a negative times a negative. That's an even number of negatives, which is positive, so I keep the plus 35x cubed y to the 4th. And here I have negative y to the 5th. That's an odd number of negatives, so it's negative minus 21x squared y to the 5th. I'm going to try to cram it in one line like y'all do to me when I'm grading your papers. Negative y to the 6th. A negative to an even power means there's an even number of negative signs, so it's positive. So plus 7x y to the 6th. And finally, x to the 0 is 1, and I have negative y to the 7th. So an odd number of negatives gives me a negative. There you go.